Alright, so now we want to know how to solve a full problem using method of undetermined coefficients. Okay, so here I have given you an example system, alright, non-homogeneous system, and I already found the eigenvalues and eigenvectors for the homogeneous version of the system. Okay, so you have to do it by yourself. Here I have given these details for you to save time on the video. So using those eigenvalues and eigenvectors, we can write the complementary function. Right, this is two distinct eigenvalues case which we have seen before. All right, so let's construct the initial guess for the particular solution first. Now if you look at the non-homogeneous part, it's t plus 1 and 3t, and if you look at those terms, those are linear terms, right? So it's like a t plus b term, but the vector version of that is, we can say a b t plus CD. Okay, so the t term and the constant term. Okay, so this is the guess for the initial guess for the particular solution. Now, okay, now we want to know whether these have an overlap or not. If you compare this with the particular solution, if we compare with the complementary solution have exponential parts in every part, right? Exponential functions in every part, but particular solution only have these linear terms of t, so they do not overlap, right? Okay, now let's write xp as a one vector, so that would be the first step after that. So we can write this as at plus c, the first row, bt plus d, the second row. Okay, now what we really want to do is we substitute this xp just like in section 4 to the differential equation, but here to the system of the differential equation. Okay, so let's see what happens in the left hand side first. So left hand side is x prime, that means the derivative of xp. So if you take the derivative here, at derivative is a, take derivative term by term, c is a constant, so the derivative is gone there, derivative is 0. So derivative of bt is b and derivative of d is 0. So this is just the x prime p. Okay, so that's the left hand side. Okay, good. Now, so now let's find the right hand side. So the right hand side really is, you have to have 1 a times 03 times xp at plus c. We have to do this very carefully. Okay, so a times xp plus f. So this is the right hand side, right? What I'm writing in red color. So now let's simplify the right hand side very carefully. So first multiply this matrix and vector. Don't add this vector to the previous vector yet. Wait until you multiply out. Okay, all right, so let's multiply 2 times the first row, 2at plus 2c plus first one time the second row. So the second row is bt plus t, so this is the first row, and 0 times the first row is gone, 3 times 3bt plus 3d. So this is what we get after you multiply these two, plus you add t plus 1 3t. Now what you get then is, if you add row by row, so 2at plus 2c plus bt plus d plus t plus 1, 3bt plus 3d plus 3t. Okay, so this is the right hand side and this is the left hand side. So now what you want to do is, these two are equal. So AB is equal to this long left hand side. Okay, so let's write it down. We have to be very careful when we are doing these problems. I think these are the most algebraically rigorous problems in our course, okay, so far. All right, now what we want to do is we want to find this a b c d, right? That's our final goal. So we take, using each row we create equations. So let's use the first row. So a is equal to 2at plus 2c plus bt plus d plus t plus 1. Using the second row, b is equal to 3bt plus 3d plus 3d. Now you might ask, well, wait a minute, that's a huge equation, right? How do you solve them? Well, here's the secret. Just like what we did in section 4.4, compare the coefficients of similar type of functions. First, take each equation, okay? Do it slowly. You cannot do it once. Slowly, slow by slow, term by term. So equation by equation. So take the first equation and compare the constant terms. On the left, constant term is A. On the right, we have a 2C, we have a D, we have a 1. So those are the constant terms. Others are coefficients of T, right? T terms. Now if you look at the second equation, so let's write constant using the constants. B on the left, here 3D, and there's no other constant terms, right? Isolated constant terms. So this is what we get using constant coefficients. Now coefficients of T. Now using the coefficient of T, left, we get two equations. Left 0. On the right, we have B plus here 1 coefficient of T, B, and also 2A. So I almost forgot. B plus 1 plus 2A, right? Coefficient of T is 1 and coefficient of BT is B plus coefficient of 2AT is 2A. Okay, so that's that. So let's write it nicely. 2A plus B plus 1. Okay, now in the second equation, left hand side no T, here 3B plus here just 3, right? Okay, so this is what we get. So we get 4 equations. Now we want to solve these 4 equations to find A, B, C, and D. Now if you look at this equation, particularly it's visible that B is -1, right? So we can get B right out of that equation. So B is -1 means D is -1/3, right? From this equation. So we use both of these equations. Okay, so that was good. Now what we want to do is, well, we can find A from this equation. 0 is equal to 2A plus B is -1 plus 1. -1 plus 1 is gone. So it seems to be like A is 0. So A is 0. So that's okay, good. So we found 3 variables. We only need to find C. Okay, so let's use this equation. Okay, so A is 0, 2C plus D is -1/3 plus 1. So let's see what we get for C. 2C, here -1/3 plus 1 is actually 2/3, right? So this implies 2C is equal to -2/3, so CT is -1/3. Alright, so seems to be like this is what we get. Okay, so we found ABCD. Now here the thing is, this is a very simple set of equations, simple 4 equations. But when you get complicated equations, you want to find out the equations that makes that you can find a certain variables very easily. Okay, I will discuss a harder problem, a challenging problem in another video. Okay, all right, so we found ABCD, and then let's write out the particular solution. XP is A is 0, B is -1 times T plus C is -1/3, D is -1/3. Okay, so that's what we get. Did we do some mistakes? I don't think so. Okay, so this is what we get. Okay, so this is the particular solution. Now I can write the particular solution in very simple manner, combining them. So if we take the first row, 0 times T is 0, 0 plus this is -1/3, -1 times T is -T minus 1/3. So this is the particular solution. Now let's write down the general solution. Okay, so the general solution is complementary solution C110 e to the 2t plus C211 e to the 3t. Those are from eigenvectors and eigenvalues, plus xp is now -1/3 -t minus 1/3. So this is the general solution for the differential equation. Little bit tedious method, right? Okay, so that is how we do it. All right, thank you.